The Casimir effect. Well, you may be wondering what that is. The Casimir effect, also known as the force of nothing, is the attraction between two mirrors in a vacuum, originally predicted by Hendrik Casimir. Imagine two mirrors in a vacuum at 0 degrees. A vacuum is a container that has been emptied of all its particles and lowered to absolute zero. The vacuum, even at 0 degrees, has vacuum fluctuations that occur, which have the average energy of half a photon. The vacuum fluctuations, as you can see here, occur on either side of the plate and also between them. These vacuum fluctuations, also known as the quantum fluctuations, occur at any point in space and change the amount of energy there for a short period of time. Due to the difference between the space between the two mirrors and the space outside, the vacuum fluctuations are either compressed or enhanced depending on the resonance of the space. And since the vacuum fluctuations between the two mirrors are pushing against the vacuum fluctuation pressure coming from the outside, it creates a net force difference where the pressure coming from the outside is greater. And one important physical quality of the Casimir effect is field radiation pressure. No matter the field, everything carries energy, and as all electromagnetic fields give pressure to surfaces, field radiation pressure increases as the energy increases, thus the frequency of the electromagnetic field. And since the resonance of the space outside the plate is greater, the radiation pressure is also leading the plates to get closer. To calculate the Casimir effect is very complicated, and until now, scientists have been able to calculate the Casimir effect when there are mirrors with the area of 1 centimeter squared and are separated by a distance of 1 ohm. In the end, the force results is 10 to the negative 7. Even though the force might be small, the Casimir force is still one of the strongest forces between two neutral objects. Well, you might be wondering, why is this important? And that's a good question, since it doesn't seem to mean much until now. However, the Casimir effect is very important and can greatly change the world of science. Even though the Casimir effect might be a very small force that occurs, when it comes to nanotechnology, it could lead to many jumps in the world of science and physics. For instance, since the Casimir force is a force that doesn't require friction, if nano devices can manipulate it, it could lead to many new devices that actually have zero friction. And if we could reverse the Casimir effect, it could actually lead to possibilities of levitation. And many research agencies like DARPA, the US Department of Defense, who develop engineering technologies, have been trying to manipulate the Casimir force. And by doing this, they could create adhesion in nano devices. Some scientists say that the Casimir effect can actually produce mass negative space-time sections, and when stabilized, it can produce wormholes, which can also allow for travel faster than light. However, many scientists say this is far-reaching and excessive. However, maybe in the future there could be travel faster than light itself with the Casimir effect. Being able to manipulate the Casimir force can cause the world of science to change, and can unlock a bigger and probably larger world of science that has to be studied. Who knows what we'll find next?